One of the other things I often hear is that wind turbine noise is masked by other ambient sounds. This is again a Pedersen study, and they took a look at what would happen if we put wind turbines along major highways. Will the sound of the highway noise make it less objectionable to the people because they're already prior exposed? What the study found was that mixing wind turbines and highway noise, there was no general masking effect found from the highway noise, except when the levels of wind turbine sound were moderate, 35 to 40, which is a level I think is reasonable, and road traffic sound exceeds that level by 20 decibels. So the masking sound was not at the same level, it was 20 decibels louder in order to mask a quiet wind turbine. Ambient sounds do not mask wind turbine noise. I have been outside near wind turbines too many hours, listening to highway noise, wind noise, birds, insects, chirps, etc. And I'll tell you, I can always hear the wind turbines. Wind turbines mask the other noises. Next slide. This is relating to the issue of computer models. When you model a wind turbine, there are standard procedures for that, as Mr. Goldberg explained, ISO 9613. But those make some very clear assumptions about the character of the noise source. And wind turbines don't fit those assumptions. This is from a 1995 document by Paul Gipp. Paul Gipp is a wind turbine advocate. He is one of the people that brought wind turbines to California. And this is from a book in which he was advocating wind turbines. However, he does believe in honesty. Multiple wind turbines complicate things further. From relatively long distances, an assembly of machines appears as a point source. Closer to the turbines, they begin to act as a line source. The decay rate for line sources is 3 decibels, not 6, for true spherical propagation. The ISO standard assumes 6 dB, that every time you double the distance from the wind turbines, you drop 6 decibels. What Paul Gipp is saying is, no, you drop about 3. Well, it's even more complicated than this. The NASA studies found that the low frequency and infrasound propagate at 3 dB in almost all cases. Whether the turbines are in a row or a line or scattered across a farmland didn't make any difference. And the higher frequencies propagate at 6. There is no standard commercial model available that follows this. There are some models being evaluated by the Swedish EPA that do it. I've built one using a spreadsheet that allows me to do it, but the commercial models do not follow any of the complexities or address any of the complexities of how wind turbine noise propagates. As a general rule, what this means is that the models underpredict what will actually occur. Now, we heard tonight that the ISO model has been calibrated to be 0.4 decibels. However, Brian Howe, a consultant to the Ministry of Environment in Ontario, where models are a prerequisite before wind projects go in, and they have many, many more wind turbines operating than we do, has been following up on complaints for the Ministry of Environment for many years, probably about 5 years now. In a paper he wrote in 2009, he said, one of the things that is still bothering him is that the models have been underpredicting the actual measured levels by 5 decibels. So when people who have no vested interest in the outcome evaluate the models, they find that the models aren't that accurate. When the consultants to the wind industry evaluate the models, oh my Lord, they're right on the money. I wonder if there's any reason why we get different results. Next slide. One of the complexities, as I said, is that low frequency sound from wind turbines propagates at a rate of 3 decibels. The green line, along the bottom, Here we have distance, 1,000 meters, 2,000 meters, 5,000. So at 1,000 meters, we're looking at about 3/4 of a mile. The green line shows the standard decay rate of 6 decibels per doubling. According to that line, if we were out at 2,000 meters, our sound level would have dropped down to about, and again, my eyes are too old, about 30 decibels. The green band shows the propagation using the 3 dB exchange, or the 3 dB propagation. And so that at 2,000 meters is almost 5 decibels louder. And as we can see, the 6 dB decay rate very rapidly drops off, and I believe the chart that Mr. Goldberg had showed this also, very rapidly drops off with distance, but with the 3 dB doubling, it flattens out, and we can find that levels are not much different at 1.5 miles than they were at 3 miles. Low frequency sound travels much farther, and part of that's due to the way air interacts, air absorption, but a big part of it is that low frequency sounds tend to reinforce when you have multiple turbines, and the sound waves get trapped, and this is from the NASA studies of 1984 through 90. The sound of the lower frequency gets trapped between atmospheric layers, bounces back and forth, and never is. Most sound, if you think of a wind turbine, the sound comes down, hits the ground, bounces off into space. But the low frequency gets trapped, and it continues to propagate then over distances that are much greater. Next slide. Now we're beginning to talk about health effects, but I want to do some history first. As Dr. Jeff Leventhal has stated, he doesn't believe that that any sound, any infrasound that is not exceeding the threshold of audibility could have an adverse effect on people. This is really not following history. We've known since the early 1970s, in fact, I have one gentleman who claims the 1960s, that there have been at least 2 issues where infrasound and low frequency sounds below the threshold of audibility have caused physical responses similar to wind turbines. The first was work on turboprop jet engines that started with Rolls-Royce, and with large diesel engines on ships, particularly military ships, where workers or sailors were being exposed to high levels of low-frequency sound in rooms, around the engine room. In both of these cases, Dr. Jeff Leventhal worked on these projects. I read his reports, and his reports state that inaudible levels of infrasound cause adverse health effects. He worked very closely with Dr. Malcolm Swinbanks, who I believe has talked to your committee at one time, or at least submitted a letter to you. Malcolm Swinbanks is one of the leading experts on low-frequency sound, and Jeff and Malcolm worked together. There's no excuse for people saying that inaudible levels of infrasound do not cause adverse health effects if indeed they've spent their career studying it and reporting on it. Sick building syndrome. Many of you probably know this term from like molds, Legionnaire's disease, etc. But it was originally coined as a term for buildings in which an incorrectly designed heating, ventilating, air conditioning system produced inaudible modulated low-frequency sounds in the work areas. Workers reported symptoms similar to those for wind turbine syndrome. This particular thing was also studied by a gentleman, Dr. Jeff Leventhal, who was hired by the American Society of Heating, Refrigerating, and Air Conditioning Engineers, and basically spent from the late 1980s through the late 1990s working on this, and identified that inaudible, modulated, low-frequency sounds in work areas from heating, ventilating, and air conditioning systems caused cognitive dysfunction, sense of motion when you're not moving, dizziness, headaches, migraines, and a general bad mood. Moods are also affected by low-frequency sound. So again, we have a person saying that inaudible,